Okay, so we're here with Stephen, and so Stephen is, I guess, one of the authors of the CUDA project, the other being Omne. We're not going to focus so much on Omne's part, which is the Sobel operator. We're going to focus more on the grayscale and the rest of the CUDA stuff. So, we're here on the Project G landing page, and what we're talking about is CUDA. And so, let's see, so CUDA is a language. I mean, it's kind of an environment. There's a lot surrounding it, but I think it's a language first and foremost. I think.
I mean, they kind of introduce it as like an API, but
API.
there's the whole language behind it, because you can do a lot of stuff.
Yeah. Yeah. I mean, I guess all the things I want to say about why I think it's more than a language, all those trappings exist with other languages too, right? But CUDA actually has like an amazing set of profiling tools and just like a surrounding environment that's really
NVIDIA
cool.
SMI.
Yeah. Actually, I don't know what that is. What is NVIDIA SMI?
Oh, it'll tell you like your jobs running. It's kind of like Top.
Oh, interesting.
But it has
Okay.
a little more kind of features.
Cool. So I mean, I guess, and so then, and you said NVIDIA. So CUDA is, we're going to say, a language for programming specifically not just GPUs, but specifically NVIDIA GPUs. And so NVIDIA made this language to really help sell NVIDIA GPUs, I guess, because it's an environment that people like to program towards, but it only works for NVIDIA GPUs. So
there's OpenCL, but CUDA tends to run a little faster.
Yeah.
And if you see CUDA cores on your GPU, that's what this is.
Yeah. So good, and then part of this is to do this assignment, you have to have access to an NVIDIA GPU, and so we have that built in that our lab has an NVIDIA GPU, and we have a mechanism for people to access NVIDIA GPUs. But the easiest would be if you have an NVIDIA GPU on your machine already, and then you're good to go. So
there may be problems with access, because if multiple people are trying to use it at once, then there can be some collision.
Correct. Yeah. So if they use our GPU, right?
Yes. They're using our GPU.
So if they use their own,
No
good to go, provided they have the right environment. If they use ours and we have too many people trying to do it at once, then there could be collisions.
Yeah.
So good. So this is, to be clear, it's not a perfect fit for a graphics class because the projects aren't really doing graphics. The projects are programming a GPU, a graphics card, but we've decided that's within scope, and I actually think a lot of people are interested in this. So thank you for putting together, this material. So I'm going to click on the prompt here, and so for the prompt, there's a series of instructions. And by the way, this is not the final version of the prompt, and so this is the prompt that Stephen produced about grayscale shading. There's two parts of the project, and the other one is on Sobel filtering, and Omne did that, and he provided a prompt, and I'm trying to get the two of them unified. And so if you look at the one that's online right now, it says just a little bit about Sobel, and Omne has more. And so what we're seeing here in this video, the prompt will be expanded, and ideally, when the people in 441 are watching this video and they click on the prompt, on the second page, this Sobel piece will be expanded. So
in case that disappears, that link in there is just to the Wikipedia.
Okay.
On it.
Yeah, it was just kind of like a stub for someone to add to. So I guess, and then so this is the prompt, and there's also some skeleton code, and I've downloaded the skeleton code right here. And so writing CUDA code in some ways looks a lot like writing C code, right? And so the syntax is the same, but there's some extra pieces that you have to do, special memory allocation, and you have to do some thinking about, because you have on a GPU so many cores, and so you have to do some thinking about, what's the kernel that you'd like to go on each of those cores, and how do you divide up the work in like a data parallel sense. And for your prompt, the data that you're parallelizing over are images, right? And then your recommendation is for each of the kernels to work on some number of pixels. Is that right? Is it one pixel or is it a group of pixels?
So the nice thing about CUDA is it kind of takes care of some of that for you.
Yeah.
So there's these threads, DIMMs, and other stuff that you'll see, and the GPU will decide how to split that.
Okay.
There are, of course, you can do anything with the CUDA language, so you can split it however you want. You may have to do some of that in the Sobel filter, which is why I gave the triple angle brackets that you
Yeah.
see down there. That's giving you a little more hint for that because that's a little harder.
Mm-hmm.
But in this section here, where you're doing your grayscale, you're going to need to figure out what you put in that angle bracket right there.
Okay, cool. And so let me say, my sense is, and you can tell me I'm wrong, but that the grayscale is going to be easier than Sobel.
Yeah.
And because with grayscale, you can just focus on one pixel at a time. With Sobel, you have to focus on the neighborhood,
Yes.
right? And so my
the neighborhood is this block shared memory down
Okay.
here.
Okay.
So I did give you some of that. You got to figure out the block or grid dim hist
Mm-hmm.
part, but
Okay.
that shouldn't be too hard.
Okay, good. And so, but people wanting to do this project would probably start with the grayscale, and it looked like they're taking one of our images from the class and they're converting it to grayscale. I'm sure that's in the prompt which image to take as input, and then after that's ready to go, probably doing the Sobel, even though conceptually it's a lot harder, it probably shouldn't be too much more work because once you've got off and going with CUDA, you're good to go.
Yeah.
Okay, great.
It's definitely the harder part, but it's more about kind of memory management and
Yeah.
figuring out some of that. Can I point that out?
Sure, whatever you'd like. Yeah.
No, I'll point that out.
I mean, that's. I think we've gotten through most of the interview. So the question is just, what more do you think we should be saying to folks?
So,
My VI doesn't work that way. You have to. Uh-oh. Okay, so you just Control F and Control B.
Okay, so I'm just in normal VI. Okay, so now
Is there another kind of VI?
well, I mean, I put keyboard
Yeah,
the
I
mouse
know.
commands in so that other people can use it.
I want my VI to be exactly like 1995.
Okay, so right here, this external share is part of that hint of you're going to be sharing blocks of memory. Same here, but basically in the Sobel, you just have to write the 2 for loops that you're going to need. You're going to have to figure that part out. But the kernels are in for you already, the width as well. So if you can just figure out the 2 for loops, you should be good. The code, I do have hints here of where to place certain memory allocations. And CUDA mem copy specifically here to make sure you do it right there. But you will notice that first we write out the grayscale image, and then after that we write out the Sobel. And the reason to do this is we're going to use this grayscale image again multiple times, and once we start messing with that, we don't want to overwrite that until we have our grayscale image. So you can mess with that data after, but make sure you get that image out first.
Good. I'm nodding over here. I want to get my nodding on camera. Okay, cool. More on the skeleton you want to say?
Can't have I have it. Yeah. Get the controls over there. It's pretty simple to run. You can put in any file you want. If you want to see how to do the switching with the command line arguments, this is how. It tells if you do nothing, if you do just a /project1g, it'll tell you how to run it. And these ones in brackets are optional. Otherwise, it has a default name, as you should see above. So it's pretty straightforward,
Okay.
I think.
Let me ask another question. Do you have a recommendation on the prompt of like how to learn more about CUDA to get started?
Yeah, so I linked 2 things here. One is to some official NVIDIA documentation. This is probably going to be the first thing you find on Google as well. The second is from Supercomputing blog, which I just like how they do everything.
Great.
So,
Okay.
and this is also a great blog for learning other things. I think they have some MPI tutorials and stuff that I've used in the past.
Okay. Cool. Cool. Well, great. Well, thanks for putting this together. I appreciate it. And so I think this interview is mostly covering the CUDA grayscale. You did touch on the Sobel some as well. Not planning on doing an additional interview with Omne about more Sobel stuff. I think you covered some, so thanks for covering that. Is there anything more you think we should say in this interview?
If if you need access to Alaska, email me.
Correct. Yeah.
So I'm the admin there, so email me.
Yeah. And your email address is in the prompt.
It's in the prompt. Yeah.
Okay. Very good. Well, thank you, Stephen. Appreciate it. Yeah.